Europa, a hidden ocean world. Jupiter's moon. Europa is a mysterious world, captivating scientists and space enthusiasts alike. This small moon, slightly smaller than Earth's moon, orbits the gas giant Jupiter and has intrigued researchers for decades. From afar, it looks like a giant ball of ice, its surface covered in a thick layer of frozen water. The icy crust is crisscrossed with dark streaks and ridges, hinting at the dynamic processes occurring beneath. But beneath its surface, scientists believe a vast ocean exists, hidden away from the harsh environment of space. This subsurface ocean, kept liquid by the heat generated from tidal forces as Europa orbits Jupiter, could be one of the largest reservoirs of liquid water in the solar system. This ocean is hidden beneath a thick layer of ice, but it might hold the key to one of humanity's biggest questions. Are we alone in the universe? The ice acts as a protective shield, preserving the ocean from the vacuum of space and potentially creating a stable environment where life could thrive. Could life exist in this hidden ocean, far from the sun's warmth? The idea is not as far-fetched as it might seem. On Earth, we have discovered life in some of the most extreme environments imaginable, from hydrothermal vents on the ocean floor to the frozen deserts of Antarctica. The possibility of finding life on Europa is incredibly exciting for scientists. If microbial life or even more complex organisms exist in Europa's ocean, it would revolutionize our understanding of biology and the potential for life beyond Earth. We know that life exists in the most extreme environments on Earth, from scorching deserts, where temperatures can soar to over 50 degrees Celsius, to the dark depths of the ocean floor, where sunlight never reaches and pressures are immense. These extremophiles, as they are known, have adapted to survive and even thrive in conditions that would be lethal to most other forms of life. If life can survive in these places, could it also exist on a moon like Europa? The search for life on Europa is not just about finding extraterrestrial organisms, it's about understanding the resilience of life itself and the potential for life to exist in environments vastly different from our own. Let's imagine we could journey to Europa, one of Jupiter's most intriguing moons. As we approach, we'd be greeted by a vast icy expanse. Our mission? To cut through its icy shell and uncover the secrets hidden beneath. What would we find? First, we'd encounter the moon's outer layer, a thick crust of ice, perhaps tens of kilometers deep. This ice isn't just any ice, it's a complex, multi-layered structure that has been shaped by countless years of cosmic activity. This ice is constantly exposed to the harsh radiation of Jupiter and the bombardment of micrometeoroids. These conditions create a dynamic and ever-changing surface with cracks and ridges forming as the ice shifts and moves. But beneath this cold, hard shell, scientists believe something incredible exists, a global ocean of liquid water. This ocean, kept warm by the tidal forces exerted by Jupiter's immense gravity, could be teeming with life. This ocean isn't just a small body of water, it's thought to be much larger than all of Earth's oceans combined. Imagine an entire world of water, hidden beneath a protective layer of ice, waiting to be explored, and because it's shielded by the ice, it could be a stable environment for life to evolve. The ice acts as a barrier, protecting the ocean from the harsh conditions of space and creating a haven where life could potentially thrive. Scientists are particularly excited about the possibility of finding microbial life in this hidden ocean. If life can exist in such extreme conditions on Earth, why not on Europa? The discovery of even the simplest life forms would revolutionize our understanding of biology and the potential for life elsewhere in the universe. As we continue to explore and learn more about Europa, we edge closer to answering one of humanity's most profound questions. Are we alone in the universe? The icy moon of Europa holds many secrets, and with each discovery we take another step towards uncovering the mysteries of our solar system. How do we know about this hidden ocean? We haven't drilled through Europa's ice, so our evidence comes from spacecraft that have studied the moon from afar. One of the most important missions was the Galileo spacecraft, which orbited Jupiter from 1995 to 2003. Galileo detected a strange magnetic field around Europa, which changed in response to Jupiter's own magnetic field. The only way this could happen is if there's a large, conductive layer beneath Europa's surface, and the best explanation is a salty global ocean. We know water is essential for life, and Europa seems to have plenty of it. Beneath its thick, icy crust, scientists believe there lies a vast global ocean. This ocean could be more than twice the volume of all of Earth's oceans combined. The presence of such a significant amount of liquid water makes Europa one of the prime candidates in our search for extraterrestrial life. But there are other ingredients that make Europa a promising place to look for life. One is energy. Energy is crucial because it powers the chemical reactions necessary for life. On Earth, we see life thriving in extreme environments, such as around hydrothermal vents on the ocean floor, where volcanic activity provides the needed energy. Europa is constantly being squeezed and stretched by the gravity of Jupiter and its other moons. This gravitational interaction, known as tidal flexing, generates internal friction within Europa. This friction produces heat, which could be enough to keep its subsurface ocean from freezing solid. This process is similar to how kneading dough generates warmth. This creates friction inside Europa, generating heat that could keep its ocean liquid. Another ingredient is chemistry. The interaction between the ocean and the rocky seafloor could create a rich chemical environment. This environment might be similar to early Earth, where life is thought to have originated. Scientists believe that Europa's ocean could contain the right mix of chemicals needed for life, including carbon, hydrogen, oxygen, nitrogen, and phosphorus. These elements are the building blocks of life as we know it. They are essential for forming complex organic molecules such as amino acids and nucleotides, which are the foundation of proteins and DNA. These chemicals could be delivered to the ocean from the moon's rocky interior, or deposited on the surface by comets and asteroids. The constant bombardment of Europa's surface by these celestial objects could provide a continuous supply of essential elements, enriching the ocean below. These impacts could also create temporary warm spots on the surface, allowing for the exchange of materials between the surface and the ocean. This dynamic environment, with its potential for liquid water, energy, and the right chemistry, makes Europa one of the most intriguing places in our solar system to search for signs of life. Section 5, the search begins, the Europa Clipper mission. To find out if Europa really does have life, we need to get a closer look. That's where the Europa Clipper mission comes in. Launched in 2024, the Europa Clipper is a spacecraft designed to study Europa in detail, searching for signs of life in its hidden ocean. The Europa Clipper won't land on Europa's surface. Instead, it will orbit Jupiter and make dozens of close flybys of the Moon, coming as close as 25 kilometers above its surface. During these flybys, the spacecraft will collect data on Europa's atmosphere, surface, and interior. Section 6. Unveiling the depths, Europa Clipper's instruments. The Europa Clipper will be equipped with a suite of scientific instruments to study Europa. It has cameras to take high-resolution images of the Moon's surface, looking for cracks and other features that could reveal information about the ocean below. It also carries ice-penetrating radar to see through the icy shell and map the depth and structure of the ocean. Other instruments will study Europa's magnetic field, measure its gravity, and analyze its thin atmosphere. All of this data will help scientists understand whether Europa's ocean is a habitable environment and if it might contain life. Section 7. A universe of possibilities, other ocean worlds. Europa isn't the only place in our solar system where we think oceans might exist beneath icy shells. Saturn's moon. Enceladus is another promising world. Enceladus is much smaller than Europa, but it has geysers that erupt from its south polar region, spewing water vapor and ice particles into space. These geysers suggest that Enceladus also has a subsurface ocean, and scientists believe that the water vapor and ice particles could contain evidence of life. Studying these other ocean worlds helps us understand the diversity of environments where life might exist beyond Earth. Section 8, the quest for knowledge, challenges and ethical considerations. Exploring Europa and other ocean worlds presents significant challenges. The radiation environment around Jupiter is incredibly harsh, and spacecraft have to be specially designed to withstand it. Landing on Europa and drilling through the ice to reach the ocean would be even more difficult and expensive. There are also ethical considerations to keep in mind. If life does exist on Europa, we don't want to contaminate it with microbes from Earth. Scientists are working on ways to explore Europa safely and responsibly, ensuring that we don't harm any potential life that might exist there. Section 9. Conclusion: Europa's promise. The possibility of life on Europa is one of the most exciting and profound questions in science. The Europa Clipper mission and future missions to this icy moon will help us unravel its secrets and search for signs of life in its hidden ocean. Europa's ocean is a reminder that our universe is full of surprises, and it's a powerful motivator to keep exploring and pushing the boundaries of our knowledge. Who knows what incredible discoveries await us as we continue to explore the cosmos?